So I'd like to thank Liv and the team here to invite me. It's a great honor. It's exciting to give this presentation. I should preface that I'm not a nutritionist. I'm not a dietary expert. I'm really a hybrid between a gastroenterologist and a neuroscientist, and have sort of used these skill sets during my career to study the interaction of the brain and the gut. So let me start with a couple of historical things. I will walk you through, well, let me say this. You're not going to come out of this talk and with a detailed instruction of what I want you to eat to be healthy. For that, you can buy a lot of books that are out there right now. Most of them are really not the whole truth, but I'm going to give you the background for you to look at your digestive system and the brain-gut axis in a totally different way, and I think that will change when whenever you eat something, you will have a very different perspective on what happens in your body. So I'm just going to start with a couple of historical slides. This shows my grandfather in 1895, I think. He was one of many generations of confectioners and chocolate makers. And that's the business that I was supposed to take over. Didn't turn out this way, but I did stick with something that appeals to the taste, and which clearly involves the brain and the gut. Another historical thing that I want to mention, so in 1929, the metaphor of the digestive system, an illustrator in Berlin, Fritz Kahn, published this book with the man as machine, and the reason I'm showing this, it sort of shows the paradigm that was predominant for a long time, actually in some people's minds, it's still the paradigm, that our digestive system is so this industrial age machine that you put things in, it's a conveyor belt, it grinds things, puts in chemicals, breaks it down, and then eliminates it. And that's quite different from where we have arrived today. So what I'm trying to convince you, and what I've done in my book, is that the model, as we always take models from the technical world to explain our bodies, and they're almost limited, but I think the supercomputer model is much closer to the way we are understanding now how the brain, the gut, its microbes, and food interact, generating ultimately health and well-being. Why did they come up with this concept of the brain-gut microbiome supercomputer? So we've known for a long time there's close interaction between the brain, the nervous system, and the gut. We knew this long before the microbes, the microbiome came on the scene. And let me show you how far this has taken us. So on the left side, we now know there's the human brain connectome effort. We know many of the networks now in the brain. There's no longer regions, but the interconnectedness of many of these systems regulate not just information goes out to our skeletal muscles, but it goes out through the autonomic nervous system into the gut. And on the right side, you see what's been evolving in terms of the gut connectome. Again, in my career, we've started with focusing on individual cells. Now we know they're all interconnected, and they generate the output that ultimately is then picked up by sensory nerves and goes back to the brain. So the brain-gut axis is this continuous circular movement between things that go on in our brain, emotions. They're always reflected in a change in the network in the periphery, and the output of this network feeds it back to the brain. So imagine you put something in like food into the lumen of your gut, a lot of things will happen at multiple levels of this circular brain-gut communication. A few years ago, some very spectacular animal experiments were published which suggested that there is an interaction of the microbes in our gut with the brain, with the nervous system. And in the meantime, we have clearly incorporated these microbes and their signaling molecules fully into this into this circular system between the brain and the gut. And I'll show you a few examples of this. A few illustrations. So some of you may have heard this, so this has almost become now common knowledge. And so the microbes, there's 100 trillion of them in our gut. If you put them together, they will be larger than either the liver or the brain. We can't see them, but if you compact them, it would be a very large organ. And some people have referred to this as a forgotten organ because we have really made all our concepts about this without taking this into consideration. It's amazing that we could actually come up with health recommendations by leaving more than half of the system out of the equation. So all the stuff that you still read in textbooks, because this has not made it into the GI textbook, is still it has to be reconceptualized and re-edited. So why are the microbes so important? Not just because of the 100 trillion numbers. Much more important is that they have the potential of doing a lot of things that we can't do. And if you compare the number of genes that they have, which allows them to produce a lot of things, then between 350 and 500 times more genes. So they can produce a lot more substances and things than any human being can do. So we're just scratching on the surface of this, what this means for us. The fact that they have all these genes, they can be activated within minutes of doing something, either at your mind level, changing your emotion, or at your gut level, putting something into your gut that they will respond to immediately. We as humans are much slower and much more limited in doing this. So there's a lot of things that the microbes can do. The most important one is it breaks down, that's probably why we developed this, they break down undigestible food products, complex carbohydrates, which are in plants, into smaller molecules. Some of these molecules are being absorbed, and you can harvest this additional energy that otherwise would be lost. So they helped us really to extract more energy out of food. The second one is, and that's kind of the most interesting one, is that many of the molecules that arise from this breakdown of these plant carbohydrates are signaling molecules that can talk not just only to the other microbes, but also to our gut and through mechanisms back to our brain. So probably this whole thing arose mainly because we humans and microbes found out that they can benefit from each other. Humans mainly extracting more calories out of what they were eating. Our hunter-gatherer ancestors were obviously dependent on that. And there's a lot of things, I mean, just showing a few examples here, a lot of molecules that are quite interesting. They can affect virtually every organ in the body. The science is mainly focused on metabolic processes, the liver, fat tissue. Our group has had a primary interest of which one of those molecules actually can affect the brain. Some of these spectacular things that have started this interest in the brain have been that it was possible to transplant a behavioral trait like anxiety from a mouse that was the other way around, from a timid mouse into a outgoing mouse, and this is obviously anthropomorphic language. And just by transferring the microbes, the behavior of that mouse would change to the donor mouse. So nothing else changed. Whatever those microbes, those substances they produce, changed the behavior of the mouse. Another one equally interesting and important, by just transplanting the microbes from an obese and a mouse with a voracious appetite, it changed a lean mouse into one that not only gained a lot of weight, but also that had the same abnormal eating pattern of unrestricted eating. Unfortunately, those spectacular findings have not been translated into human studies. A lot more difficult than in these artificial mouse experiments. But certainly it started a lot of enthusiasm, a lot of potential for obesity, metabolic syndrome, and there are many studies going on with fecal microbial transplantation, antibiotic treatment, and so forth. Why would these microbes be able to talk to us? So most people would think, well, the microbes learn it from us, but in reality, over billions of years, microbes have lived in the oceans and have developed these 500 genes, 500 folds, millions of genes really, to synthesize these communication molecules that allow them to talk to each other. And when they decided to settle in the gastrointestinal tract of the first primitive marine animals, the two found out that this was a very beneficial relationship, and that stayed for the rest of evolution. This symbiosis stayed for the rest of the time, and the neurotransmitters that we have now in our gut, in our enteric nervous system, and in our brain really originated from this genetic information that the microbes developed over a long time. So we're intricately, over billions of years, connected to that world of microbial communication, and probably have a lot to learn from it. And very important to say that I think we're just really at the very beginning of understanding the implications for our health and for disease. So this just illustrates the transition of these very primitive nervous systems from the first marine animals to our first gut, which was really the gut in the brain in our gut, ultimately into our nervous system. All this originates in this vast experience and information that the microbes developed while they were living without any mammals or any humans around. Let me say one thing about gut reactions and gut feelings, something everybody uses this term. When I wrote this book, I realized, paying attention to it, it's not a day that goes by in the press that people would not talk about. They made a decision with their gut, or they had a gut reaction. It's present in every language, so it's something very fundamental that people have experienced. And so let me just give you two examples. The one is the top-down, the gut reactions, how the gut reacts when you are in an emotional state or when you're stressed. If you don't have one of those disorders, these stress-sensitive disorders where you get stomach pains when you're stressed or anxious, it happens all the time. Your emotions are reflected, a mirror image in your gut function, the secretion, the contractions, the blood flow, and now also the microbes. We know that these signals that go down from the brain, specific for every emotion and stress, will directly talk through this shared language to your microbes and will change what they do to the food that you eat. So when you eat a meal, when you're angry, anxious, or stressed, you will process this food very differently as if you're relaxed, happy, in a pleasant social context. This is illustrated here. So just like as everybody can tell if you're angry or anxious by looking at your face, your facial muscles, the gut does exactly the same thing. So you may not feel it, but it has a big impact on how your gut processes the food. The other way around is equally intriguing, possibly more intriguing. And I've used in a book this analogy to the Google search engines. So there's constantly a huge amount of information flow from the gut, including all the chatter of your microbes, into centers of the brain. And all these signals are being stored. You may not feel them. You may not have the cramps. But all these, if you're in a situation that is upsetting, is threatening, you will store this vast amount of information at your brain level and later be able to recall it by accessing this vast database. It's just like the Google search engine. Last year, I was at this art exhibition in Venice, the Biennale, and I saw this interesting screen where hundreds of these little videos were playing, and each person was telling an emotional story from their life. And I thought this is the perfect analogy to what happens in our brain. We have billions of these emotional moments with their gut sensation stored there, and when we make a gut-based decision, our brain can access them within milliseconds without going through a logical, linear attempt to come up with a conclusion or with a decision. So I can't prove this, but I think it's a very tempting model or analogy to understand that. So food, microbes, and the brain. As I mentioned before, food interacts with the microbes with many sensors in the gut, and this information makes it to the brain, and then the brain responds in a circular fashion on the right side to influence contractions and bowel movements. One signaling system is particularly intriguing. So if anybody is in here who takes, it's probably not the case, but if anybody took an antidepressant, serotonin reuptake inhibitor, you would think that this medication acts on your brain, on the serotonin system. But we know now that only about 3% of your entire serotonin is in the brain. All the rest is in the gut, in cells that are influenced by the microbes. The microbes actually can influence the synthesis of this substance. And these cells then can feed it back to the brain into centers that deal with your regulation of emotion, sleep, appetite, and well-being. So you have almost your own Prozac factory in your gut, and the microbes play a big role in this. We're just at the beginning. Psychiatrists have refused to really look at this for a long time. Most of them still are not aware of that connection, but it obviously opens up a lot of intriguing possibilities, not just for pharmacological treatment targeted at this gut system, but also in terms of how food and different food components, by changing your microbes, can influence that and generate well-being and affect all these other vital functions. Another system of great importance are these inflammatory cells. So the circled type of cell in the lining of the wall are these dendritic cells. They're immune cells, and they have these little tentacles that stick out into the lumen of the gut and have receptors. The microbes talk to those as well. So there's an ongoing dialogue to your gut-based immune system, and the immune cells then signal this back up virtually every organ, particularly interesting to the brain. Why would this be important for diet? So the inflammation doesn't occur because you have a gastroenteritis, but it's modulated to a large degree by the food that you eat. We know that food with a high animal fat content and with a high degree of unsaturated fatty acids will activate your microbes to release a substance called LPS, so lipopolysaccharide, which increases the leakiness of your gut and then gets into these immune cells and triggers this whole cascade of a systemic low-grade immune activation, including effects on the central nervous system. So it's now believed that it's not only your adipose tissue that produces inflammation through this mechanism, because these signals go to the fat cells as well, but it's also the brain, and that a chronic influence of that low-grade inflammation on the brain may play a major role in neurodegenerative diseases such as Parkinson's disease and Alzheimer's disease. So that's a very intriguing aspect that links, and there's already now studies just recently published from UCLA, for example, that a particular diet together with other lifestyle factors can slow the development of Alzheimer's in high-risk patients. So probably that mechanism is at the bottom of that. So the question is always being asked, is there an optimal diet? And so this is not something that people have asked just now in the last 10 or 20 years, but this has been at the center of attention for many ancient healing traditions. So the modern answer to this question, is there an optimal diet, is can see here, and you get these very contradictory answers. So a clean gut versus eating dirt, eating fat to get thin versus eating complex carbohydrates, and then the grain brain, which basically recommend that all grains and which contain many of those, the whole grains, many of these complex carbohydrates that the microbes is food for the microbes, that this would cause all kinds of diseases, including brain diseases. So I had the pleasure and the privilege to participate some 30 years ago in a film expedition to the Yanomami Indians in Venezuela on the Orinoco River, and I never thought that would come back to me 35 years later in terms of optimal diet, the question of optimal diet. So we lived with these people for 4 weeks, ate the same things that they ate, observed that they have a very high, about 80% complex carbohydrate diet, very diverse, that they collect from the jungle, small amount of animal products, and that they had several hundred herbal medicines that they used to stimulate their, to use for various diseases. So these are some of the few remnants of hunter-gatherers in the world. Another entity are the Hasda in Africa, totally different environment, but very similar dietary habits. The same kind of hunter-gatherer diet with small amounts of meat, virtually no animal fat, and large amounts of complex carbohydrates. Now, the reason I got sort of led back to this was when a paper was published by Gloria Dominguez from NYU, where they looked at the gut microbes of those Indians that lived very close to the Yanomamis, not identical, but. And the main thing was they and the Hasta have the greatest diversity and abundance of gut microbes of any known human being in the world. Several-fold higher than individuals in North America. And that goes all the way down to newborn infants that already have, in this country, the same depletion of the microbial diversity. So this is obviously now that we think that the diversity is one of the main determinants for gut health and probably also health in general. This obviously is a big warning sign. What are we doing in westernized societies? What are we doing to our life, to our diet primarily, in order to result in this decimation of our inner microbial world? Another jump, not expected, but I have found in my travel and sort of reading that there are diets, not the extreme of vegan or the diets free of any natural grains, that there are diets out there that are actually not that dissimilar in their composition overall of large amounts of varied complex carbohydrates from plant-based food and small amount of animal products, and both mainly in terms of chicken and fish, which is the Mediterranean diet. If you look at the pyramid based on that, it's interesting. So it just summarizes what I said. The biggest portion are these plant-derived foods. At the bottom, it's important. So we talk about the mind-brain-gut axis. It's not just what goes on, what you put in, but also the state of mind you're in. So many investigators that studied the extensive health benefits of this diet, not just on brain health, which is totally about the recent Alzheimer's study at UCLA, but also in metabolic health. It was the social interactions that these investigators commented on that were a major determinant how successful this diet was in enhancing well-being. Is this Mediterranean diet beneficial for our gut microbes? Here are some reasons. As I told you earlier, one of the main reasons we developed the microbes or this cohabitation is because the microbes break down plant-based carbohydrates and generate these signaling molecules to the rest of the body. They also have anti-inflammatory effects against this low-grade immune activation. And then clearly the Mediterranean diet has something that is not directly related to the microbes, is this high level of antioxidants from olive oil and red wine and nuts and berries. Probiotics. So we are going to have the pleasure to taste some fermented food. Clearly that's been another unique feature of the North American diet, that it has until recently completely eliminated fermented foods from the staples. And there's been a lot of hype now from animal studies. Probably one of the biggest ones is psychobiotics, that you may be able to treat depression and anxiety with the intake of daily probiotics. I can assure you that's almost certainly not the case. There's a lot of work going on in developing novel probiotics, that some of them are engineered to produce something that, like an antidepressant. Others are combinations of human microbes that produce short-chain fatty acids, which are anti-inflammatory. We're just at the beginning. The ones that you currently can buy, and there are hundreds, will not do that. They will not act as antidepressant. However, there's pretty good evidence that a regular intake of fermented food, that natural fermented food that contains different types of lactobacilli and bifidobacteria, that it will benefit the diversity of your gut microbiome and will make it, because of that, more resilient to perturbations through infections or stress. But just summarize this now. I hope what I've tried to do here is to get across a very different way of thinking about how our mind, the environment, the brain, and the gut, and its internal environment interact with each other. It's clearly no longer possible to have these simple linear models. I take one pill and that gives me optimal health. I think any intervention has to involve strategies that aim at the brain, at the mind, and our internal ecosystem to maintain the diversity. And we can do this through a combination of relatively easy lifestyle changes that involve things like mindfulness-based stress reduction, healthy eating, conscious eating, and sticking to some fairly simple dietary recommendations that hopefully I gave you some rationale why they might be beneficial. Thanks for your attention.
Thank you so much. Dr. Mayer, you are the director of the Oppenheimer Center for Neuroscience, and
neurobiology of stress and resilience.
Stress and resilience. So I want to go right there. What does resilience look like? Let's just assume most of us in this room are stressed, let's say. No. What does it look like? If we are resilient, how are we eating? How are we thinking? How are we behaving?
Yeah, I mean, certainly, most of the research over the years has focused on the stress part and the negative part and the damage it can do. It's gradually changing in the scientific world. Still very difficult to get grants on the positive aspects, resilience, and this whole ecological perspective on health. So starting with something as focused as the gut microbiome, how do we optimize the resilience? And the current concepts are based on ecological theory. The more diverse and the more abundant the organisms are, the more is it able, this system, to either bounce back from a perturbation like an infection or a major stressor, and even not being affected to the same degree. Keep in mind that the stress I mentioned will always, you may not notice it, but it will always affect your gastrointestinal activities and your microbial world inside. About 10% would, I'm not sure, so Googlers are a very special selection of people, so that these statistics may not apply, but in the general population, about 10 to 15% of people have digestive issues that are typically stress-related. We have to assume that their resilience is to those perturbations is decreased, and what we recommend when I see patients like that have the symptoms, to really target both the brain, the mind part, and the dietary part, the gut part. What can people do in here? I mean, there are simple techniques. One is clearly the healthy diet, the anti-inflammatory diet that prevents these, what I mentioned. So the worst thing that you could do is to eat a high-fat diet and be stressed. Makes you feel better temporarily, the concept of comfort food. But in the long term, it enhances this inflammatory reaction and has detrimental effects on your brain health and general health. So the dietary awareness. And the second thing is, I would never leave the mind out of this. Mindfulness-based stress reduction, abdominal breathing are very simple techniques that everybody can use to enhance that state of resilience.
So we actually teach mindful cooking and mindful eating in this kitchen. I hope all of you will look into that. So when we're doing all-nighters and putting out a product, pizza and French fries is not the thing to have.
It feels the best because fat will. This has been shown that particularly animal fat will temporarily downregulate your stress system in the brain, but in the long term, it will have the opposite effect. It will lead to these, long-term low-grade changes that will make you more likely to be chronically stressed and develop all kinds of things. From the metabolic syndrome, which is also a low-grade inflammatory condition, to heart conditions. So, yeah, the challenging thing is to be aware that these comfort foods are the worst thing that you can do in order to maintain or enhance your resilience. You're drawn towards them. That's why companies you see it on TV in the evening. It's all high-fat food, but I think it's very important. This concept of this low-grade inflammation, you don't want to have your body in that state all the time, day and night. So, I think if you only take that message home, I'm sure nobody has these unhealthy eating habits here, but a lot of people do, and it's tempting. Work late and let's get a pizza. And
So, what does low-grade infection feel like? Am I not sleeping well? Am I likely to bite off the head of somebody I work with? What does it look like?
So it's low-grade inflammation, not infection. There's no organism involved other than the microbes that produce these substances. It's something that you don't feel, unfortunately. At some point, you may feel exhausted, fatigued. So chronic fatigue syndrome would be like the end stage of that process. But a lot of people lose their vitality, and just don't feel right when they wake up in the morning. And keep in mind, it sort of starts a chain reaction because exercise. So there's several factors that influence that low-grade immune activation. One is your diet, so very important. Another one is stress. Another one is physical aerobic exercise, which down-regulates it. And sound and healthy sleep is also a major factor to down-regulate this inflammatory state. So I think what's happening is we're slowly developing a very comprehensive model of health and well-being, this systems view, with the low-grade activation of the immune system being the common currency for many of these influences. If you only do one, it may not harm you. If you do more than one, it will gradually have this accumulating effect. And a lot of people, if you go out in the street and see obese people, they don't feel it right away. And some people may be very healthy even though they have a high BMI. But if several of these factors come together, then you clearly play with your health.
Is the brain the last thing to go? Is the fogginess or the I'm not thinking as straight as I used to, is that an indicator, and is that kind of more a final stage indicator?
It's not really I would say, Alzheimer's disease is a final stage, but the brain fog, a lot of people have this, and the loss of vitality and sense of exhaustion, it's definitely not the end stage. It can come fairly early. It can come, before somebody starts overeating or have other health issues. And it pretty depends on the genetic vulnerability. Some people are more vulnerable to one organ over the other. So if you have genetic predisposition for Alzheimer's disease and have a lot of relatives with it, then I would be particularly worried about the brain being affected by these factors than if you don't have these risk factors. Same family history for heart disease, family history for obesity. So the human genes set the stage of where the damage occurs first. Some people get the full hit that all organ systems are affected. In others, it's selective, and in others, they're so resilient that they will not. There's a lot of people with very unhealthy lifestyles and being stressed, and will not get the full damage that you would expect in a situation like that. So,
I'm not sure. So you're asking how the genetic material and what you feed your gut interact with each other?
Number one, what's the significance of that?
Yeah, so I can answer this.
What's the significance of that?
So first of all, the options that the microbiome has to adapt to new situations, be it signals coming from the brain or coming in through nutrition, or they have been able to adapt to eating seaweed. So most people in the world don't have microbial capacity to break down the carbohydrate of seaweed. But in Japan, they have developed it through eating seaweed on a regular basis. There's other examples. There's what microbes also do. They break down many of our drugs, so-called xenobiotics. These are substances that have never occurred in evolution, and the microbes, through this combinatorial possibility, can develop strategies to break them down and inactivate them. They also, through these, probably people are familiar with this concept of epigenetics, they can influence our own cells, the immune system during development, the first 3 years of life. There's a lot of interactions, and clearly the microbes have much more to say because they have a lot more capacities to talk to our immune system and to our nervous system. So I didn't get to this in my talk, but I believe, and quite a few investigators believe, that the biggest influence of these microbes is early in life, prenatally in the first 3 years of life, where many of these systems are being established and set up. Once they're programmed, both the brain and at the gut level, they remain fairly constant. They vary in a certain bandwidth, but you don't change them fundamentally. So I think the main interest, including the probiotics and nutrition, it should really focus on these first 3 or 4 years of life, starting during pregnancy. I think that's most data suggests that.
Yes.
On that vein, my first introduction to this topic was in New York. The Museum of Natural History had a big exhibit on the microbiome, and they mentioned the importance of, for example, like vaginal birth and breastfeeding on introducing that microbiome to an infant. I'm wondering, what is your thoughts on how, as C-sections increase in our population, and as let's say bottle feeding increases in our population, how can we introduce these really important microbiomes to our infants and our children?
Yeah, so this would be the topic for a whole talk, really, because it starts during pregnancy. The stress of the mother affects the mother's microbes, including the microbes that live in the vaginal canal of the mother. The baby is born, it goes to this canal, it's like the first contact with microbes. And it's been shown in animal studies that a stressed mom will transmit a different set of microbes to the infant, and these mice have different brain development. So it starts to stress the nutrition of the mother, the metabolites get towards the infant. Breast milk is a huge component. There's the so-called human milk oligosaccharides, or HMOs, that are contained in breast milk, which are specifically targeted at feeding the microbes. So humans cannot absorb those or do anything with them. So breast milk produces those to target the evolving gut microbiome of the infant. So if that's altered, the whole program will be off. And I've talked to experts in this field. I mean, they say that, but it's not just the breast milk. The breast milk, for example, of these Yanomami Indians and moms in North America is fundamentally different, because the nutrition of the mother really affects that. So this whole, what we see also with the diversity of the microbiome starts really with the diet of the mother that affects the breast milk and affects these human milk oligosaccharides. So it's a major complex. I personally think in 10 years from now, the microbiome field and the probiotic field will mainly focus on this period.
Is there anything that can be introduced for children who aren't breastfeeding that can kind of...
Well, I think the only thing that you can do is, same thing that you would do as an adult, non-pregnant adult, to eat a healthy diet and learn to deal with stress better. I often see it with with some postdocs who get pregnant and then they work on a grant 1 week before delivery and come back a week later. This is really insane. Well, when you think about it, the potential consequences of that, now that we know many of these connections, is definitely not worth it.
Do vegetarian or vegan diets reduce the diversity of the microbes in our stomach in a negative way?
No, so as I said a few times, the main food for the microbes and why they evolved is to use these complex plant-derived carbohydrates, these complex molecules that we as humans can absorb. Many mammals can't do that either. I think humans have gotten better since they discovered the fire to be able to cook things so they easily break down. But even cooked food will still have a very high percentage of those substances. So if you want to do something to feed your microbiome, a vegetarian diet can't really compare vegan and vegetarian in that respect, but it's the main thing is this high percentage of these plant-derived foods. And I think that is the key also when I sort of made this huge jump from the Yanomami to the Mediterranean diet. It's the common principle that underlies that.
Since I was a little girl, and I'm sure a lot of you have also heard the same, we've heard this phrase, "You are what you eat." But as I've gotten older and I've seen family members in the hospital or in hospice, or I've talked to friends who have gone through medical school, nutrition and food isn't discussed, or it's skimmed over, and they look at me like I'm crazy when I'm talking to them about probiotics. Why do you think there's such a big disconnect? Why are my grandparents being fed horrible food when they're trying to recover from illnesses? And why am I getting, ice cream in the hospital?
Yeah, no, this is an excellent question. And, I've been trained as a gastroenterologist at UCLA and have never been exposed, so we deal with gastrointestinal disorders, never been exposed a single minute to anything that had to do with nutrition. And so it's I'm not sure why we have developed, there's two things in medicine. One is, medicine basically has not paid attention to the brain and the mind. Now this whole mindfulness revolution is kind of really taking traditional medicine by surprise because they never pay attention to it. And nutrition is the other aspect. It's still today, I would say in most training programs for health professionals, it's not a mandatory component. The good news is, I was mentioning this earlier, so some of the UC campuses have really started these campaigns, similar to what you do here in this kitchen. This healthy campus initiative with a healthy food component, healthy mind component. It's extremely popular among students. I think there's phenomenal involvement in both UCSF and UCLA. The goal is to become the healthiest campuses in the world. That's kind of the mission statement. So that's almost starting a revolution, but it's outside of medicine. It's amazing. It comes, even though all these data come now from medical science, the practice in medicine has not changed really.
Can you say anything about glyphosates and the impact on the gut and implications of that?
Yeah, the glyphosates. Yeah, so this is this substance in Roundup, which is genetically modified food. Mainly is modified in order that you can kill off everything else, but not the crop that you want to have. And it's kind of fascinating. When you read up of how this was approved, it was approved on the lack of effects on human cells in a test in a petri dish on a short-term basis. So this was done long before the whole microbiome science came on board. And it's not really been repeated. So these early experiments suggested that humans do not metabolize that substance, so do not get the toxic effects, the cells at least. But now we know that the microbes can break it down can activate it into a substance that is really harmful to us. So not only is it bad for some of the microbes, but also for our own gut health. And it's been interesting to me that this whole GMO debate has always been about the potential harm of the genes, which I'm not so sure if they are really that dangerous to humans. I mean, to the environment they are probably, but the main danger I think comes from these chemicals that are being given at higher and higher doses because there's resistance developing, and without ever having studied the impact on the microbiome now with all the things we know. So it's really amazing that people will not. So I had a venture capitalist coming down once who asked me this question and said, would you be willing to do a study to look at that, and what would this cost? And so we talked this through, and you would probably have tremendous resistance at every level to do a study like this. It is a multi-billion-dollar business, like the tobacco industry. I think the reason there is no research is probably for that reason. People are afraid to get into this.
Hi, what are your thoughts on fasting?
Yeah, fasting is an interesting thing. So first of all, there's a diurnal rhythm to what the microbes do, both their numbers and what they produce. So when you sleep and no food gets into your intestine, it's a completely different setup than when you are awake. So compromised sleep, which means compromised fasting, because many people get up and eat something, usually fatty and sweet things. The other thing has not really been studied so well. I've always had this philosophy: if something has been around for a long period of time, like the fasting tradition, fasting practice in all the major healing traditions, there must be something to it. I would imagine it's a reduction. It's clearly, one is a reduction of the numbers, which is temporary. The other one is that the microbes. So there's another source of food for the microbes, which is the mucus layer of the gut, and so when you don't feed them, they go after that mucus layer and use that as a substitute. And so it will definitely affect that layer that separates us from the lumen, from the inside. That mucus layer is a big part of the leaky gut concept. So it's not just holes in the wall, but it's this mucus layer. So if this strengthens the barrier function of the gut, I would say most likely has a health benefit. I would not, dismiss that. Not enough research on that topic, unfortunately.
Is there proof that eating probiotic food increases the amount of bacteria in digestive system?
Yeah, so there's a couple of things to it. So the first person who sort of propagated probiotic yogurt was the scientist Mechnikov, who also got a Nobel Prize more than 100 years ago. But what he realized that he had to eat it continuously in order to have the benefits. And that's one limitation for if you are the occasional yogurt eater, or if you go and buy your pills when you don't feel right. If you change your dietary habit chronically or constantly, I think that's really required to get the health benefit. I don't think by going on a 2-week course of taking your probiotic pills will really have any significant effect. And so we have done a study where we looked at the changes in the microbial architecture with a 4-week intake of a probiotic-enriched yogurt. And there was no change in the architecture, in the players, but the signaling molecules that they produced changed. But only as long as you took it. The minute it would stop it. So I think, so I mentioned this earlier, probiotics early in the first 3 years of life and during pregnancy, probably a very big impact. The same impact, and this is my personal opinion, there's no science on it. If you are on a diet that's enriched in fermented foods, you will have it will have a sustained benefit. But you have to stay on that diet. It's not like, let's go once a week in a restaurant and eat kimchi or a sauerkraut dish. You know, it has to become, like in the Korean culture, I mean, it's really integrated. And that's also been interesting when I was working on the book to realize how important that is. I think there was a time during the war where Korean soldiers would refuse to fight because there was a threat that they wouldn't have their kimchi. That kind of shows how dependent they became on this, possibly through some changes within the brain, or they just feel different. But the key thing is the regular intake. It cannot be the occasional, breakfast yogurt and.
Thanks so much. So what can we, rather than taking probiotics, what can we eat? Complex carbohydrates, it sounded like. What can we eat to nurture our bacteria, our gut bacteria? Well, you talked several times about a healthy diet. You mentioned the Mediterranean diet. Can you say a little bit more? What can we do to nurture our gut bio?
If you take, there's a lot of these. So a lot of diets nowadays recommend what you can't eat. I'm always amazed, like you buy something, a drink, and has 5, no gluten, no sugar, no. I think you really have to think much more about the other way around. What should we eat? And plants in general, a high variety. So one is the high variety because each plant has a different composition of these molecules. A large amount, which is not just good for the microbes, but it also has a lower caloric density and glycemic index, so your insulin won't go up. And all the plant-based oils, which are generally low in these saturated fatty acids, on top probably the olive oil is probably on top of all these, but avocados, so anything that has fat in it and comes from a plant doesn't have the inflammatory effect that you get with the animal fats. So I don't think you have to pick any particular vegetable or any particular, it's variety, and it's the relative proportion in the overall food intake. So that's different clearly than what you would get from any specialized cookbooks that you have to eat this particular thing. And there's other substances which goes beyond the microbiome, more into this low-grade inflammatory state. So turmeric, for example, has these anti-inflammatory properties, and I'm sure there's other. I mean, I said in the beginning, I'm not a nutritionist, so I can't really give you this in detail, but there's a lot of plant-based foods that have these anti-inflammatory properties, and so that's another thing.
More plants.
More plants, a lot more plants.
Thank you very much.
Thank you.